I'm Mr. Green here. I'm going to take you through the next lesson on the electricity topic of the Physics AQA GCSE Combined Science. This lesson is on electrical energy transfers. Your learning objective today is to recognise electrical energy transfers and calculate energy for circuits. You can pause the video and take that down as your learning objective. Okay, start as we always do with some retrieval questions. Please pause the video whilst you answer those questions and restart when you'd like the answers. Okay, question 1. What's meant by electrical current? That's the rate of flow of charge. So charged particles such as electrons, how quickly they flow, that's the current. What are the units? Units for current are amps, and that is symbolised by a capital A. What's meant by potential difference? Potential difference is a measure of how much energy is transferred between 2 points in a circuit. And what are the units for potential difference? That's measured in volts. Question 5. What equation relates current and potential difference to each other? That would be Ohm's law. Potential difference equals current times resistance, or in symbols V equals IR. Pause the video and make sure you've got those answers correct. We'll move on to the lesson once you've unpaused. Okay, our learning outcomes today are to perform calculations for energy transfer in circuits using PD and charge, and relate energy transfer by charge to different electrical components. So, what is the energy transfer? If we look at that circuit diagram that's on there, can we describe the energy store changes within this circuit? The chemical potential energy of the battery decreases as it transfers energy by an electric current via the electric pathway. This increases the thermal energy store of the bulb and the variable resistor, so that energy is being transferred from chemical to electric to thermal. The energy is transferred then to the surroundings by heat and by radiation in the form of light by the bulb. So energy transfer. We've got our next equation we need to learn. E equals V times Q. Those symbols mean this. Energy transferred equals potential difference times by the charge. So the amount of charge that flows multiplied by the potential difference tells us the energy that's been transferred. Energy transferred is in joules, potential difference is in volts, and charge is measured in coulombs. So coulombs, this is the measurement of charge. There's our equation triangle for those of you that like to use them. Again, write that down and cover up the value you're trying to calculate. What remains tells you the equation you'd need to use. So, a quick example. Calculate the energy transferred if the potential difference is 120 volts and the charge is 4 coulombs. So, energy equals potential difference times charge. Potential difference is 120 volts. Charge is 4 coulombs, so we do 120 times 4 to give us 480 joules. Remember, we're measuring energy. Joules is a measurement of energy. Calculate the potential difference when the energy transferred is 700 joules and the charge is 5. So we'd need to rearrange our equation. We know that energy equals potential difference times charge, but we want potential difference to be the subject. So we need to rearrange it to make V there the subject. We need to move Q over to the other side of the equal sign. So when we do that, we do the opposite of what's happening on that side. Giving us potential difference is energy divided by charge. Energy is 700. Charge is 5, got both those values from the answer. So it's 700 divided by 5 to give us charge, which is 140 volts. That should be Q, not E, I do apologise. Quick revisit. How can we calculate charge in a circuit? Well, we need to know the current and we need to know the time the current flows for. Current is the rate of flow of charge. That tells us how many coulombs are flowing per second. So if I know 10 coulombs flow per second, I know in 2 seconds that'll be 20 coulombs. In 10 seconds that'll be 100 coulombs. So our equation for this is charge equals current times time. So we get our current, we get our time in seconds and work out the charge. So in this case, how much charge flows if a circuit with 500 amps is switched on for 5 minutes? Pause the video whilst you attempt that question. Okay, so first off, we need to convert our time to seconds. It's no good having it in minutes, that doesn't work for us. So We know there's 60 seconds in a minute. We've got 5 minutes, so that's 5 times 60, giving us 300 seconds. We then use our equation. Charge is current times time. Current's 500 amps times 300 seconds. 500 times 300 gives us 150,000 coulombs. Okay, so with that in mind, could we attempt these 3 questions? You'll need to rearrange the equation for questions 2 and 3, but using Q equals IT, calculate those, pause the video whilst you do that, and restart when you would like the answers. Okay, question 1. We know Q equals IT, charge is current times time. In this case, the current's 12 amps, but the time's been given us 30 minutes. We need to convert that into seconds. So that's 30 times 60, giving us 1,800 seconds. Charge is current times time, so that would be 12 times 1,800, giving us 21,600 coulombs. Question 2. What's the current if an appliance has 180,000 coulombs of charge flowing through it for 10 minutes? You'll see again, we've done the same thing there. We've been given it in minutes, we need to convert that to seconds, but first we need to rearrange our equation. Charge equals current times time, so if we rearrange that, current equals charge divided by time. Charge is 180,000, and time, 10 minutes, so we need that in seconds. 10 times 60 is 600 seconds. To get our answer, current is charge divided by time, that's 180,000 divided by 600, giving us 300 amps. And finally, number 3, the time an appliance with a current of 15 amps using a total charge of 500 coulombs has been left on for. Again, we need to rearrange our equation. So Q equals IT, so therefore T equals Q divided by I. We've moved I to the other side of the equal sign, so instead of timesing it, we divide it. We know charge is 500 coulombs and current is 15 amps, so that's 5,000 divided by 15, giving us 333.33 seconds. Bit of a flourish, you can change that to 5.5 minutes by dividing it by 60. Okay, the reason I've gone through that equation is we will need it for this question. Calculate the energy transferred if the potential difference is 120 volts and the current flowing for 4 seconds is 0.75 amps. So to calculate the energy transferred, we need the charge. We're not given the charge in this case, we need to calculate the charge. So we calculate the charge by Q equals IT. Charge equals current times time. We know our current and we know our time. Current's 0.75 times 4 seconds. Multiply them by each other, we get a charge of 3 coulombs. We can now answer the second part of the question. Energy equals charge times potential difference. Charge is 3 coulombs, we've just worked that out previously. And from the question, potential difference is 120 volts. So that's 3 times 120, giving us 360 joules. With that in mind, pause the video and try and attempt these 5 questions. Pause the video whilst you attempt them and restart when you'd like the answers. Okay, question 1. Voltage across the resistor is 6 volts. How much energy is transferred when 7 coulombs of charge flow through it? That would be 42 joules. Question 2. How much charge flows if 90 joules of energy is transferred when the voltage is 12 volts? That would be 7.5 coulombs. If 0.5 amps flows for 1 minute through a bulb and the potential difference across the bulb is 5 volts, how much energy is transferred? 150 joules. Okay, for question 4, a bit more involved. For the circuit below, the resistance across the bulb is 10 ohms. How much energy is transferred in 10 seconds? So we're not given the charge, so we don't know what the charge is at the moment. So, we know V equals IR. We've got the voltage, that's 6 volts. We know the resistance, which is 10. So voltage divided by resistance, 6 divided by 10 gives us a current of 0.6 amps. We then do Q equals IT. 0.6 times 10 gives us 6 coulombs. We now know our voltage, we know our charge. Voltage is 6, charge is 6, 36 joules. Question 5. For the circuit below, if the resistance across the bulb is 20 ohms, how much energy is transferred in 10 seconds? Well, it's a parallel circuit and we know the current across each one is 1 amp. The bulb, though, comes before the parallel circuit. So 1 amp plus 1 amp would be 2 amps. The current is 2 amps. We know Q equals IT. So we know our current, which is 2. We know the time's 10 seconds. 2 times 10 gives us 20 coulombs. V equals IR. So 2 times 20 gives us 40 volts. 2 was the current, resistance is 20, 40 volts. We've got the values we need now to calculate energy. Energy equals charge times voltage, 20 times 40, giving us 800 joules. Okay, quick exam question. This is for the foundation paper, so attempt this one. When the potential difference between the Van de Graaff generator and the Earth's sphere is 80 kilovolts, a spark transferring 0.00002 coulombs of charge jumps between the metal dome and the Earth's sphere. Calculate the energy transferred. Pause the video whilst you attempt that question. Okay, so we know that energy equals voltage times charge. So that would be 0.0002 times 80,000, giving us an answer of 1.6 joules. Okay, slightly more difficult question now for the higher paper. The charge that flows through an electrical device in 180 seconds is 5,400 coulombs. The new electrical shower has a power of 5 kilowatts. Calculate the resistance of the heating element in the new shower and write down any equations you use. Pause the video whilst you attempt that. Okay, so we know that Q equals IT, we know that charge is current times time. We want to find out what our current is, so we divide charge by the time. 5,400 divided by 180 gives us 30 amps. So we've now got the current and we've got the power. Do we know an equation where power, current and resistance are related? Well, we do. P equals I squared R. So rearrange that equation. R equals P over I squared. Resistance is power divided by current squared. That would be 5,000 divided by 30 squared, giving us a final answer of 5.5 ohms. Okay, I hope that was useful. We do have lots and lots of videos on our YouTube channel on electricity, on energy, on all aspects of physics and biology and chemistry. Please have a look through there and see what you find useful. I hope you found this one useful. See you soon. Goodbye.